Hi viewers, I am producing these videos to support teachers of mathematics in helping learners make sense of mathematical concepts and their associated procedures and processes. And today I'm going to look at the column addition algorithm. And I'm going to use the Dienes blocks just to help me model what this looks like and how we might make sense of this. So if I start with a number, say 432, then I can build this using the Dienes. And at the minute, I've got the Dienes in 3D, which is obviously what they would be as a concrete manipulative. But as I'm not intending to use the 1000 block today, I'm going to switch them around to 2D just to make it a bit simpler to see. So here is my number, 432. And then let's say I want to add to that the number 321. So I can set up my number 321. And so now what I want to do is I want to add these things together. Well, of course, in this sort of view, I'm in effect using area here to model number. So each of these numbers is being modeled by the area it takes up. So we've got 100, 200, 300, 400, and 32 squares of area. And similarly here, 321 squares of area. When we're modeling in a continuous way like this using area or length, then addition tends to be seen as just connecting these together. So what I'm going to do now is I'm going to connect these together. Now, because of the numbers I've chosen, it doesn't actually matter whether I connect the hundreds together, then the tens, then the ones, or if I connect the ones, then the tens, then the hundreds, or even if I connect, the hundreds and then the ones and then the tens. It really doesn't matter here at all. So I could just say, right, well, I'm going to connect these 100 areas together, which has given me a total area of 700. And then I'm going to move my ones a little out of the way so I can connect my tens together. There we are. And that's given me a total of 5 tens. And then I'm going to connect my ones together, and that's given me a total of 3 ones. And so altogether, I've got 753. So why then in the column addition algorithm do we generally start with the ones? Well, of course, generally we start with the ones because there might become times where I might have too many ones to represent as ones, and I want to exchange those ones for some tens, or some tens and ones. And that's going to cause me a problem if I've already evaluated how many tens I have. And I'll give you an example to show you what I mean. Let's say I take the number 476 this time, and I want to add to that the number 325. So I'm going to build those numbers. Here's my number 476. So there's 476. And then I'm going to build my other number here, which is 325. And so what I could do is do the same thing as I did last time. I could connect these things together in order to add them and say, right, well, if I connect my hundreds together, then I'll have 700, so that's fine. And then if I move my ones out of the way for a minute, I can connect my tens, and I'll have 9 tens, so that's fine. And then when I start to reconnect my ones, of course, this is where I'm going to run into a bit of difficulty, because, and not difficulty necessarily with making sense of the adding, but a bit more difficulty with the recording, because now if I start to connect my ones, I can see that I reach this point where I have enough ones to make a 10. So I would want to exchange those 10 ones for a 10. So now, having already evaluated there were 9 tens, I've now got to change how many tens I've got. But not only that, what makes this one even worse is having got that 10, well, that is the 10th 10. So actually now I could be exchanging all of those 10 tens for a single 100. And so I have to go back and change all of this now to say, oh, well, actually, no, I was wrong. I actually had 8 hundreds, and I've actually got no tens because I've exchanged all my tens up for the next 100. But I do have this 1. And so you can see that this just gets a bit messy with me having to go back and forth in evaluating how many tens and hundreds I have. Whereas if instead of that, of course, if I hadn't done that, and if I'd have actually had the presence of mind to start by collecting my ones, then if I again take my number 476, there it is, 476, and my number 325. There it is, 325. Then if I started collecting my ones, well, I could have said, right, well, actually, I'm going to start collecting my ones. And at this point, I have enough ones to exchange 10 of my ones for a single 10. So what I'm going to do here is say, right, well, I'm going to exchange that for a single 10. So that would just leave me with having a single 1, but now I've inherited an extra 10. And now I can collect my tens together, move that 1 out of the way, and collect my tens together and say, right, well, with the 7 tens I started with, plus that extra 10, plus these 2 tens, I actually now have 10 tens, but that's enough to exchange for an extra 100. So now I have actually no tens rods left at all because I've exchanged all of those for 100 rods, but I do now have an extra 100 rod than I had before, or an extra 100 block, sorry, that I had before. And so now I can finish off by collecting together or connecting together my hundreds blocks. I have my 400s from before plus this extra 100 that I created from my tens, and now if I connect together my remaining hundreds, I can see that altogether I have 8 hundreds, because I have my 4 and my 3 from my 2 original numbers, plus the extra 1 I got from collecting my ones and creating the extra 10, and then that extra 10 connecting with the other 10s to create the extra 100. And so I can see why the answer to that is 801. And it's worth doing that with learners. You know, it's worth exploring with them a little bit, using Dienes perhaps as to, you know, why actually the column addition algorithm does make sense generally to start with the ones, but that perhaps there are times where you don't need to do that in order to be able to add those numbers. And of course, that's all part of achieving fluency with addition, is when can I be flexible with these procedures, and when does it make more sense to follow these procedures more rigorously. And I could do the same thing as well with place value counters. Now, if I'm going to do place value counters, then we need an understanding, or learners will need an understanding of the fact that 10 tens make 100 and 10 ones make 10. And you can see that in the Dienes. You can see 10 tens making 100, or you can see 10 ones. It's not that one. Here it is. You can see 10 ones making a 10. But you can't see that in the same way with the place value counters. So place value counters require that underlying understanding of place value before they can be used. But if I have that underlying place value, then actually the sort of flexibility you get with place value counters, you can deal with much bigger sums. You've not got as much space taking up, so it tends to be a little simpler to set up. So here is my 400 and 76. I'm going to pop the last two underneath there. And then here is my 325. And again, I'm going to pop the last one underneath there. And now again, if I work in exactly the same way, I can see, well, if I start by collecting my ones, I can put these ones collected, but that these ones should group into a single 10. And so I get my extra 10. And then I can collect my 10 tens together, but they should group into, I might have to put them next to each other to make it work here. They should group into a single 100. And for some reason, they're not doing that. Perhaps if I put them on top of each other. So if I stack them up, there we are. They've grouped into a single 100. And so now I can see, and I can follow that that's exactly what I did there. I put 6 and 5 ones together. That made a 10 with an extra 1, and we can still see my extra 1 hanging around down here. And then I group my 10s together, and the 10 tens group to make an extra 100, so I have 800. In both cases as well, we can show this in a table form. So I could put my hundreds in here. I could put my hundreds in here. I could put my 10s in here. And I could put all my 1s in here. And you can, if you're using this particular virtual manipulative, then I can change that table into powers of 10, base 10. I can also bring in fractions and decimals when I'm ready to look at decimal place value and addition and subtraction of, or addition of decimals or something like that. And again, I can bring in something like a numerals table here where I can put my 1s or my 100s in. Or I could put that table in words instead of numerals if I wish to. So that's just a short video on how we might support learners making sense of the column addition algorithm and when we have to apply it rigidly, when we can be a little bit more flexible, but in particular using the manipulative to support what is actually going on when we're exchanging these 1s for extra 10s or exchanging these 10s for extra 100s. As always, I'd like to say thank you to mathsbot.com and its creator, Jonathan Hall, for the superb website, which not only houses all of these virtual manipulatives that I'm using in my videos, but has loads of other materials available for teachers of maths. And if you've never been to mathspot.com, then I very much recommend you do so and check out what's on offer there. It's all free, and there is loads and loads of great stuff for teachers of maths. And if you are interested in working with manipulatives and visuals, then I would also urge you to check out my website, visiblemaths.co.uk. And in particular, amongst the many things you'll find on there, one of the things you'll find is a link to my book, Visible Maths. And you can see that on the publisher's website. You can have a look at some samples. And if you feel like it will help you to develop in this area, you can, of course, purchase a copy. I am creating these videos throughout lockdown and potentially beyond if I continue to have a bit of time. So if there are any videos you would particularly like me to make and any ideas you'd particularly like me to see explore with manipulatives, then please do get in touch and hopefully I'll be able to create something for you. Thank you very much for listening.